Hello everyone, welcome to my youth programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is number of longest increasing subsequences. So those of you who do not know what a subsequence is, a subsequence is a subsequence of an array. For example, the array is given like this: 1, 2, 3, 4, 5. The elements of array are like this. So a valid subsequence is a sequence of numbers which can be obtained by deleting some or zero elements of array, provided the order of elements in subsequence remains same as that of array. So for example, here a valid subsequence can be, let me quickly change the color, 1, 2, 4, 5, but it cannot be 1, 5, 2, 4, since the order of the elements in the subsequence is not same as in that of array. So it's not a valid subsequence. It's a valid subsequence, it's not a valid subsequence. And you may choose to delete choose to delete any of the all of the elements also, and a empty sequence is also a subsequence, and you may not choose to delete any of the elements, and a full sequence 1, 2, 3, 4, 5 is also a valid subsequence. Since you chose to delete zero elements, it's up to you whether you want to delete some elements or zero elements, provided that the order of the elements in the subsequence remains same as that of array. So this is what a subsequence is. Let's come back to the problem statement. Given an integer array nums and return the number of the longest increasing subsequences. Increasing subsequence is, for example, this is a increasing subsequence. Here the order is like this, but this is not a increasing subsequence since the order is like this. And first of all, this was not a valid subsequence of this, and if at all it were a valid subsequence of some array, then the numbers are not in increasing order, so it would not be a valid subsequence. Valid increasing subsequence. And you have to note this, note that the subsequence has to be strictly increasing, means it cannot be the case like, for example, 1, 5, 5, 6, 7 is not a strictly increasing subsequence, because two elements are here equal. All the previous elements should be lesser than the current element and not equal to it, then only then the subsequence would be a strictly increasing subsequence. So what we will be doing is, let me quickly clear the board. Yeah, now let's go to the constraints part. The length of the array is given of the order 2000. So for every element in the given array we have two choices. Let's say x is the longest increasing subsequence. For every element in the array, we have two options: either to include it in the longest increasing subsequence, or to exclude it in the longest increasing subsequence, or to exclude it. So for each element we are having two choices: either to include it or exclude it. For a longest increasing strictly increasing subsequence, then let's say for n elements we would be having 2 raised to power n choices. Here the number of elements is of the order 2000, so 2 into 2000 is much greater than 10 raised to power 8, which are the number of operations allowed in 1 second. So our solution would give us TLE, and to get our solution accepted, we have to optimize on this approach. So how will we approaching this problem is, and those of you who do not know how the time complexity of a accepted solution varies according to input. Size, I'll provide a link for that. Now let's say for element 3, to check the longest increasing subsequence that would be ending on element 3, let me quickly clear the board. Let's say a subsequence longest strictly increasing subsequence ending at 3. So subsequence is like this, it ends at 3. So what would be the length of this subsequence? So the subsequence will be like, for example, all the numbers should be smaller than 3, and all the numbers in the subsequence, the previous one should be smaller than the current one. Let's say it's x is x plus 1, it's x plus 2, and this is 3. So you can see, if you consider this as the current element and this is the previous, so previous is clearly smaller than the current, so it's a strictly increasing subsequence. So for every element we have to traverse back in the array. For every subsequence ending at an element, we have to traverse back, and it will, and for this element also we have to traverse back, and to find the size of the subsequence that end on this element, we have to traverse back, and to find the element on the size of the subsequence, strictly increasing subsequence ending on this element, we have to traverse back. So it will give us TLE, since the solution would be greater than of the order of n square time complexity. TC would be much greater than this. So what we will do is, suppose we store the length of the one smaller number than 3, a length of the subsequence, let me quickly change the color, length of subsequence ending at a number smaller than 3 and which is at left side of 3. 3 is the current element being considered. So if we somehow know what is the length of the longest strictly increasing subsequence ending at 2, let's say let's call this variable x. If we know the value of x, we can simply write x plus 1 would be the length of the subsequence ending at 3. Since adding 3 to this subsequence would only increase the length of this subsequence ending at 2, strictly increasing subsequence ending at 2 by 1 only. So for all the numbers lesser than 3, we would be checking the length of the longest increasing subsequence ending on those numbers, and will take the maximum out of them and we'll add 1 to them, and for this would be the answer for maximum longest strictly increasing subsequence ending at 3. I hope till now it's clear. This is the whole crux of the problem. Now let's move towards the coding part, and then you can see how we will count the number of longest increasing strictly increasing subsequences. So what we have done is, if the length of the array is 0, we are simply returning 0. Since the subsequence of 0 size are not counted, and then we'll simply be storing the length of the given nums array, and then actually the length is counted and the maximum number of subsequences would be 0, since there would be no subsequences. So we are storing here the size of the array, and then what we are doing is we are considering a length of the length array. This length array is for let's say, what is the let's say this is the length array. Ith element, the element at ith index, second index, denotes length of strictly increasing subsequence ending at nums of index element. So I hope it's clear. Then count will be count of number of subsequences of length index. Every index in count array denotes this length of subsequence of length index, this length. I hope it's clear. Then we'll be for a element, let's say I, we'll be traversing back and finding the elements which are lesser than the current element. So I here, I is the current element which is being considered the end of current subsequence. If let's say a subsequence is ending at the ith index, then we will be checking all the numbers that are lesser than the number at the ith index, and for the length of the strictly increasing subsequence ending at those numbers, we will be adding 1 to it, and if it's greater than the current length of the subsequence ending at the ith index number, then we will be updating it. And also in this case, if the size of the subsequence is increasing, so we are encountering this size for the first time, this is for encountering this size. What is the size? Length I for the first time. So we won't be changing changing the number of such subsequences. We will just be copying from the previous smaller element from whose length we have copied and added one to it. And if the size remains the same, it means we have encountered this size longest. We have encountered this sized longest, this sized subsequence, strictly increasing subsequence before. So we'll be simply adding the count of the subsequence ending at the number lesser than the current number, and we'll be moving ahead in this fashion, and along each for each element in the array being considered, we'll update the longest increasing subsequence. And once we have the length of the longest increasing subsequence, LIS is length of longest increasing subsequence. And once we have this length, we'll simply traverse the counts array, and these are the number of longest strictly increasing subsequences. We'll be adding the number of such subsequences to the final answer, and we'll be returning it. I forgot to mention strictly here. So this is the solution for this problem, and the code will be available in both C++ and Java. And another thing to be noted is we can also find this index which is just smaller than the element being considered with the help of binary search also. Think upon it. If you are unable to implement such a solution in which binary search can find the just smaller element for the current element, I'll be more than happy to share the code with you. You may ask for it in comment section, and yeah, that's the solution. And subscribe to my channel for more such content. Thank you very much for watching. Thanks.